Imagine, just for a second, discovering a massive body of water so enormously vast that it actually holds more water than every single ocean on Earth's surface combined. Now imagine that this ocean isn't out there on some other planet and it's not tucked away in some unexplored subterranean cave system like you'd see in a sci-fi movie. Instead, this incredibly vast reservoir is buried nearly 700 kilometers directly beneath your feet. Today, we're diving into what is absolutely one of the greatest geological discoveries of the 21st century. It's a true game changer that fundamentally rewrites how we view the makeup of our planet and the very origins of our surface water. All right, let's start by looking at our planet from the inside out. Earth is basically made up of four main layers. First, there's the incredibly thin outer shell we call the crust. That's where you, me, every city, mountain, and surface ocean exists. Right beneath that lies the mantle, which is this massive layer nearly 2,900 kilometers thick. And while it's made of solid rock, the sheer heat and pressure down there allow it to flow very, very slowly over millions of years. Go deeper, and you hit the outer core, a swirling sea of molten iron and nickel. And finally, at the very center, the inner core, a solid metal sphere that's literally hotter than the surface of the sun. For a long time, scientists actually thought they had a pretty solid grasp on these layers. But then we started looking closer at part one, the transition zone, located between 410 and 660 kilometers deep. For decades, this specific deep boundary layer deeply puzzled scientists. To really put our actual physical reach into perspective, 12 kilometers. That is the maximum depth of the Kola Super Deep borehole, which is the absolute deepest hole humanity has ever managed to drill into the Earth. Compare that 12 kilometers to the 410 kilometer starting line of the transition zone. No human and no human-made machine has ever come remotely close to reaching this region. So that brings us to a pretty massive roadblock, right? If we can barely even scratch the surface of the Earth's crust, how could scientists possibly know what exists hundreds of kilometers deeper? I mean, we obviously can't just send a camera down there. Instead, scientists had to rely on one of nature's most powerful and often destructive forces to act as their investigative tool. And that tool, seismic waves, which are generated by earthquakes. Whenever an earthquake hits, it sends these massive ripples of energy racing through the entire planet. Now, as these seismic waves pass through different materials like solid rock, molten iron, or even partially melted magma, they actually change their speed and their direction. By studying these tiny, subtle changes using vast arrays of seismometers, scientists can effectively map the hidden interior of the Earth. It essentially acts just like a giant CT scan for the planet. But here's where it gets really interesting. As scientists analyzed mountains of this seismic data, they noticed something highly unusual. The seismic waves were unexpectedly slowing down when they hit certain regions of the transition zone, specifically around 600 kilometers deep. Now, in the world of geophysics, when a wave slows down like this, it usually points to one very specific thing: partial melting of the rock. But why on earth would the rock be melting down there? The answer to that mystery comes down to a stunning little blue crystal called ringwoodite. It's a super rare, high-pressure mineral phase of olivine. And the amazing thing about ringwoodite is that it acts essentially like a sponge. Under the immense, literally crushing pressure found hundreds of kilometers beneath the surface, the totally unique crystal structure of this mineral has the incredible ability to attract hydrogen and actually trap water directly inside of it. Now, I want to make a really crucial distinction here about what we mean when we use the word ocean in this context. When you hear underground ocean, you probably picture vast, dark, liquid seas, maybe underwater caves, or flowing underground rivers. That is absolutely not what is happening here. Instead, we are talking about hidden water. The unimaginable weight of 250 miles of solid rock, combined with extreme temperatures, actually causes water molecules to split apart. This forces their hydrogen and oxygen atoms to become chemically trapped inside the solid crystal structure of the mineral itself. It's really a fourth form of water. It's not liquid, it's not ice, and it's not vapor. For years, this whole waterlogged transition zone idea was just a theory based on laboratory experiments. But then came the massive breakthrough in 2014. An international team of scientists was examining a tiny, battered diamond that had been violently carried all the way up to the surface by a volcano in Brazil from about 550 kilometers deep. And trapped right inside that diamond was a microscopic piece of natural ringwoodite. It was the very first one ever found on Earth's surface. And when they finally tested it, it contained about 1% water by weight. It was the exact smoking gun scientists had been searching for. That tiny microscopic inclusion inside a diamond literally transformed decades of theory into hard, undeniable fact. It proved that the transition zone wasn't completely dry. In fact, if the ringwoodite spread throughout the entire mantle contains just 1% water by weight, which is exactly what the samples and seismic models suggest, we are talking about a deep reservoir that holds as much water as multiple surface oceans combined. We're talking perhaps up to 3 times the volume of every single ocean on Earth. But we do need to stay grounded in the reality of what this environment is actually like. This unbelievable volume of water is bound under crushing, almost unimaginable pressures and temperatures that easily exceed 1,000 degrees Celsius, often soaring way higher than that. It is a profoundly harsh, dynamic, and extreme environment that is completely alien to any water reservoir we interact with on the surface. All of this naturally leads us to a pretty massive question. If there is just so much water hidden deep inside our planet, locked away in these blue crystals under immense pressure, well, what role has it actually played in shaping the Earth we live on today? Because a discovery like this doesn't just update our map of the Earth's interior, it completely shifts our baseline understanding of how the whole planet functions. Which brings us to part 2, the deep water cycle, essentially Earth's hidden plumbing. For an incredibly long time, scientists heavily debated where Earth's water actually came from. Was it delivered by icy comets striking the early Earth, or did it slowly originate from within the planet itself? Well, it turns out our planet has this massive, completely hidden plumbing system actively at work over millions of years. Here's how it goes. Step 1, tectonic plates on the ocean floor slowly subduct, meaning they slide beneath one another, dragging water-soaked minerals way down into the mantle. Step 2, these minerals, which eventually form our friend ringwoodite, carry that water deep into the transition zone. Step 3, as that mantle material gets pushed even deeper into the lower mantle, the rock's structure changes and it simply can't hold water anymore. It literally sweats the water out, causing the rock to partially melt, a process called dehydration melting. And finally, step 4, this newly freed water and magma eventually make their way all the way back up to the surface, released through volcanic eruptions, returning the water right back to our atmosphere and oceans. Because of this continuous deep water cycle, this hidden reservoir isn't just sitting there. It's an active, driving force of our planet's entire geology. It drives rock melting at depths we previously didn't even think was possible. It fuels the huge volcanic eruptions that build land masses. And crucially, it literally lubricates the Earth's interior, enabling the very movement of tectonic plates over massive spans of geological time. Honestly, without this deep, hidden water, Earth would just be a geologically dead planet. It would look drastically different than the vibrant, living world we know today. It is honestly, truly a marvel of modern science. Think about it. A vast, hidden world dictating the very life cycle of our planet's crust. And it was revealed to us entirely through the abstract patterns of earthquake waves and microscopic mineral samples trapped inside volcanic diamonds. It's exactly like scientists managed to put together a million-piece puzzle without ever once being allowed to look at the picture on the box. Which leaves us with a rather profound thought to end on. If an ocean 3 times the size of our surface waters can just stay completely hidden 700 kilometers beneath our feet for the entirety of human history, only revealing itself to us in the last decade, what other incredible secrets are still waiting to be discovered deep beneath the ground we walk on every single day? The Earth is clearly far more dynamic and mysterious than it appears, and our journey to really understand it is, in many ways, just beginning. Thank you so much for joining me for this explainer, and I'll see you next time.